Okay, question number 71 over here is a hydrocarbon having molecular formula C5H10 produces a tertiary alcohol upon treatment with a few drops of concentrated sulfuric acid and water. The same hydrocarbon, when reacted with acidic potassium permanganate, produces a ketone and a carboxylic acid. Now, suppose there is a double bond, and if this on cleavage, which is oxidative cleavage by the potassium permanganate, okay, in presence of acid, obviously. So if this is giving a ketone, say this is R1, this is R2, and acid, okay, say it's giving C double bond O, and they say this is R3. If these two molecules are coming, then obviously the over here the alkene should be having a structure of this type, in which this is say R3, R1, and this is say R2. Now if you check all the options, we have given cyclopentane has no double bond, so no case of oxidative cleavage. We have been given a pentene, so out here we can see nothing like this is present, okay. Even in case of a 2-pentene, we can see there are two hydrogens, okay. But in case of the 2-methyl-2-butene, which is something like that. Now if you think of cleavage using KMNO4, so this one undergoing cleavage, this is the hydrogen. So surely we are getting a ketone, and this portion is going to produce C double bond O and OH. So that is a carboxylic unit. Okay. So our answer over here is going to be C. Similarly, if you had treated this with the concentrated H2SO4, few drops in water, the alcohol that would have been formed after the electrophilic addition reaction would have been this 3-degree alcohol as the major product over here. Okay. Next we will a pink colored aqueous solution of cobalt nitrate turns blue on addition of HCl. Gradually the color change happens due to the formation of. So it is basically a well-known question from the coordination chemistry. The cobalt nitrate dissolves in water to form the pink hexaqua complex, which if you treat with chloride, okay, and in excess amount, say, this will transform to a tetrahedral COCl4 2- species, okay, and this one will be having a blue color, whereas this is having light pink color. Okay, our answer over here is going to be A. Next question is asked over here. 50 ml of 0.1 molar of a weak acid is titrated with 0.1 molar of NaOH. The ionization constant of the acid is given over here, which is Ka 1.8 into 10 to the power minus 5. Using this information and from the options given below, the best indicator for the titration of HA with NaOH. So this is given by the expression which it says pKa plus minus 1, okay, to get the range under which the indicator should, to get the correct indicator one should use, okay. So for that, if we calculate the pKa value, it is coming out to be, as we know, we'll say minus log to the base 10, 4.8 into 10 to the power, sorry, it is not 1.8. So this is going to come out to be as minus log 1.8 into 10 to the power minus 5, close bracket. It's coming out to be as around 4.74. So if it is 4.74, then if we do pKa plus minus 1, then the values we are getting over here is going to be 3.74 to 5.74. Okay. So if we check the values now, we will say the indicator best possible over here is going to be the methyl red, because it ranges from 4 to 6.3. Okay, and these values are very much close to it. Okay, consider a PV graph diagram given below where an ideal gas is reversibly converted to state A to state B. That means from here to here. And this is a isobaric process. Volume is expanding, so obviously the entropy is increasing in this process. That is for sure. And out here in this process, under this particular curve, we will say pressure remains constant. Okay, so if we say PV equal to nRT, this being same or remains constant for this process. Okay, if you want to convert this curve into TS curve, if this remains constant, right, and volume is increasing, then the temperature should increase. That should be the case over here. So the curve that should be formed over here is going to be this one, in which the entropy is increasing and also the temperature. So correct answer will be over here, C. And that should end our questions over here.